This is tutorial for boundary layer number 8. Determine the equation for drag coefficient CD for a 1/7 power turbulent velocity profile, and the Blasius resistance equation is given as this one. So for Blasius resistance equation, bear in mind that you may see two type of them, but it actually shows the same terms. So sometimes they use mu over rho u delta here, and sometimes it use nu over u delta. And then you need to understand that mu is actually is rho equal to rho nu. Okay, please bear in mind the difference between dynamic viscosity and kinematic viscosity here. So as we know, the 1/7 power law is actually it will create velocity profile of y over delta by the power of 1/7 here. And this is the shear stress for the Blasius resistance calculation. First, we could calculate the value of theta from this velocity profile. From this equation, we could get that theta is equal to 7/72 delta. And then we substitute the value of delta here in von Karman equation. We could write tau is equal to rho u square d delta 7/72 delta here. And then we equalize with the shear stress from Blasius resistance calculation, and then we could calculate the value of delta. So the detail about this calculation is given in previous lesson. You may check that. So the delta is equal to 0.3721x Reynolds number by the power of 1/5. So and then the value of delta here, we substitute in the value of theta that we get previously. So we substitute with this one, we could say that theta is equal 0.036x over Reynolds number by the power of 1/5. To get the value of drag coefficient, so we need to divide the total drag force with 1/2 rho u square BL. BL here is the area of the flat plate. And drag force can be calculated by integrate tau b dx, which tau is the shear stress, b is the width of the flat plate, and dx is the small part of the length or the x-axis of the flat plate. So next, we substitute the value of tau here with the von Karman. So it become rho u square d theta dx here, and then we bring out your rho u square b here. We have d theta dx over dx. We could simplify or cancel off the value of dx here. We cancel off the value of rho u b here, and then what we have here is integration of d theta. So it can be written as integral of 1 times d theta, and it will give us the value of theta here. So we could simplify the value of CD here into 2 theta over L. So then 2L here, and we substitute the value of theta, and finally we could get the CD of 0.072 over Reynolds number by the power of 1/5. So with this calculation, we could say that another way to calculate the value of CD is by calculating with 2 theta over L. So this is might be another method to calculate the value of CD.